In this section, we're going to look at how do we solve systems of linear equations in three variables. Okay, so objectives we're going to look at is how to verify a system and also what the system looks like. We're going to solve systems of linear equations in three variables, and then we're going to solve application problems. Right. So the process is geometrically equivalent to finding the points of intersection, not of three lines, but of three planes in space. Okay. So what we might have is on a three-dimensional axis. Okay. And for those of you that are going really high in your math careers, you'll see this, but we might have a plane in space, and we might have another plane in space, and we might have a third plane in space. And geometrically, the place where these intersect would be the solution. Okay, so now it's really difficult for us to be able to visualize this. Okay, so that's why we don't have a geometric solution. And plus, we probably need to be in Calculus 3 for us to be able to really see the three-dimensional plane system and learn the equations and all that stuff. So we're just going to go ahead and be able to solve these algebraically, right? The solution is going to be something called an ordered triple. Okay, so an ordered pair is x, y. An ordered triple is going to be x, y, z. Okay, and it's going to satisfy all the equations in that system. Okay, and the solution set is going to be the system of all the solutions within that system. Okay, so let's do a really basic example, and let's just show that -1, 2, 2, or -1, 2, -2 is a solution to this system. All right, so that means that x is -1, y is 2, and z is -2 in this ordered triple. Okay, so it goes in the form x, y, z in that order. Okay, now let's substitute into equation 1. And so if we do so, we're going to get -1 plus 2 times 2 minus 3 times -2 equals 9. And then this gives us -1 plus 4 plus 6 equals 9, and that's a valid statement. So the first equation's good. For equation 2, we're going to get 2 times -1 plus, or minus, excuse me, +2. And then finally, plus 2 times -2. Okay, that's supposed to be -8. Okay, so let's see if that's valid. -2 times 1, -2, minus 2, and then 2 times -2, and that should be -8. And certainly, we know that -2 minus 4 is going to be -8 equals -8. So the second equation is valid for -1, 2, and 2. Finally, equation 3, substituting, we get the opposite of -1. Okay, so substituting here, plus 3 times 2. Okay, so substituting 2 back in for y, minus 4 times -2, and that's supposed to be equal to 15. Well, -1 times 1 is 1, 3 times 2 is 6, -4 times -2 is 8, and so we end up with 15 equals 15, and yes. Okay, so the answer would be that it is. Okay, so we're going to say since -1 to -2 satisfies all three, it is a solution. It might not be the only solution, but it is a solution. All right. So now what we're going to do is we're going to take a look at the process of being able to solve this system. Okay, that's going to be a pretty rigorous process. So when we solve the equations, what we're going to do is we're going to try to reduce the system to two equations in two variables. Okay, so that's the trick. What we're going to do is we're going to use the elimination method on two of the three equations. Okay. Now, of course, we could go through and use substitution. Doesn't mean that we can't. But this is just one of the methods we can use. Then we can go ahead and solve the remaining the two equations by using either addition, elimination, or substitution. Okay. That means we get one variable. Okay, the solution. So then we're going to back substitute that value. And then we're going to go ahead and find this, we're going to find the solution to the remaining system. Okay. Then we're going to back substitute again, and then we're going to check the proposed solutions. Okay. So there's basically a lot of elimination and substitution going on here. So let me show you the process of this, okay? So we have x plus 4y minus z is 20, 3x plus 2y plus z is 8, and then 2x minus 3y plus 2z is negative 16. I'm going to pick on the first two equations, okay? And I'm going to add those together because I notice that I have z's that are opposite. Excuse me. So if I add those together, I'm just going to take these two equations off to the side. So x plus 4y minus z is 20, and then 3x plus 2y plus z is 8. And so if I add these together, those are going to cancel out. I get 4x plus 6y is going to be equal to 28. Okay. Now I'm going to hold on to this equation. Excuse me. Now what I need to do is I need to pick on two different pairs of equations. Okay. I'm going to pick on these two pairs. Okay. So I'm going to have x plus 4y minus z equals 20. And then 2x minus 3y plus 2z equals negative 16. And I'm going to try to eliminate the z's from here, okay, because I eliminated the z's from these two, from the first two pairs, all right? So that's what you're going to do. You're basically going to find two pairs of equations and try to eliminate one variable. I'm going to multiply the first equation by 2, okay, so I'm going to cross multiply that by 2, and I'm going to multiply the second equation by 1. And so that's going to yield the system 2x plus 8y minus 2z, excuse me, is going to be equal to 40. And then the second equation remains unchanged. 2x minus 3y plus 2z is negative 16. And now we can add these two equations. We're going to get 4x plus 5y, and then 40 minus 16 is 24. All right, so these two equations that we just generated, okay, so this equation and this equation, now we're going to make a system out of these. Okay, so that's the trick, is that we have to eliminate either the x, the y, or the z. I just picked on the z's because they were opposites already, okay, in two of the equations. I did do a little bit of work in the other one to get rid of it. Okay, so let's go ahead now and solve this system. Okay, so we have 4x plus 6y is 28, and then 4x plus 5y is going to be 24. Let me multiply the first equation by negative 1. Because what that'll do is that'll give me the opposite of 4x, and then I can eliminate the x's. So I would get negative 4x minus 6y is going to be 28, negative 28, excuse me. And then 4x plus 5y is going to be positive 24. These cancel. Negative 6 and positive 5 is a negative y. Negative 28 and positive 24 is a negative 4. And so that means that y is going to be equal to 4 for us. Now I'm going to substitute 4 back in for y. And it doesn't matter which equation. I'm just going to pick the second equation because it was closer on the keyboard. So 4x plus 5 times 4 equals 24. This is 20, so I'm going to subtract 20 from both sides. So I get 4x equals 4, and then we divide by 4, and now we get x is equal to 1. Finally, I'm going to go all the way back up to the beginning, and I can pick any of the equations. I'm just going to pick this one because, I don't know, because z is readily available. Okay, so there's no coefficients in front of z except for positive 1. So that means we get 3x plus 2y plus z, right, is equal to 8. Now we know that x is 1, and we know that y is 4. Right? If we combine these, that's 11. So 3 plus 8 is 11, plus z is 8. And if we subtract 11 from both sides, we get that z is negative 3. Okay? So our ordered triple, okay? So remember, an ordered triple is the solution. We have x is 1, y is 4, and z is negative 3. Okay? And that's going to be our solution for this, right? If you wanted to check, what you would do is you would take that and substitute it into all three of these. Now, I'm just going to substitute it into this first one just to check, all right? Um, just because I figure if it works in two of them, we're assuming it works in the second one because that's the one we solved. Let's see if it works in the first one. Okay, so we have x plus 4y minus z is 20. Okay, so just to check. So we have x, and I forgot it, plus 4y minus z is equal to 20. All right, so just checking one more time. Yep. All right. So we have 1 plus 4 times 4 minus a negative 3 is equal to 20. Okay. And we don't know if that's true or not. So this is 1 plus 16, which is 17. Okay. So this is 17 plus 3, which is 20. So it looks like that at least it checks out for two of the three equations. If it checks out for two of the three, it's most likely going to check out for all three. Okay, so that's how we solve by using our methods for three equations and three variables. All right, we'll take a look at another example in the next video, and then we're going to go ahead and take a look at some application problems.